The music graph is a tool for creating dynamic audio and background experiences in Tetrio. It requires a bit of setup, so before we get started we have to actually enable the music graph. Open your main Tetrio Plus window and enable the Custom Music, Music Graph, and optionally the Remove Built-in Music option. Now, we also have to add some tracks to play from the music editor. Open the Music window, and then click the large Upload Music button and select the tracks you'd like to upload. Now you'll have to put these into the disabled song pool so that they don't play in-game while you're trying to play them from the music graph. So set them to disabled. You can do this faster using the table view. Once you're done with that, go back to your main Tetrio Plus window and select the Open Music Graph Editor option. This is the Music Graph Editor. Right now it's fairly empty, and to get started we have to add some nodes. Nodes are the basic building block of the music graph. They work kind of like a flowchart. Unlike a flowchart, you can have multiple active instances of a node at the same time. Each node has a number of triggers. Triggers describe an action that occurs when a specific event is received. Global events are generated by the base game and activate triggers. There are also a handful of local events which don't show up in the debug menu. There are several types of actions called modes that a trigger can perform. Goto and fork allow changing or creating nodes. You can also destroy the node instance. Create is a special case of fork that can create a node from a global event without needing the node to already exist. Dispatch allows you to create your own events, which is the main way to communicate between active nodes. More on that later. Random is used to generate random target events on the node, which allows you to pick another action at random. And set mode allows you to set variables on the node, which we'll also cover later. Each node can have an audio track and a background image. When that node is instantiated, its audio will play and the background will show. When you load up the game, the only node you'll have to start with is the root node. There's nothing special about this other than that you can't delete it and you always start with one. To get to other types of nodes, we'll need to use a trigger to create them. This will use a Sound Effects Go Player event, which fires when a game starts. And we will use the fork mode, which creates a new node without affecting the current node. Now we'll need to create a node for the trigger to focus on. Call this music. Then we'll change the target of our trigger to this new music node we've just created. Then we'll need to set music that we want to play on the music node. Now save our changes. This will automatically update the graph in game, and we can go and start a game. Now, as you can see, our music has started playing, and a blue dot representing the music node has forked off from the root node. Now, by itself this isn't very interesting, and it also doesn't loop. If we want to get our music to loop, we'll need to use a node end event that goes to the current node, which means that this node, when it's over, will start itself again. Now, this by itself isn't very interesting. We could get the same effect by simply adding the music into the normal music editor. But what we can do is if we add a new node here and call it Music Plus 1, we can use a more interesting event, such as the FX Line Clear Player, which will fire when you clear lines. Now, this comes with a parameter which allows you to say how many lines are required for this to fire. So let's say we want this to only work when there's at least 4 lines cleared. For this we'll put in this expression, $, which represents the number of lines cleared. This varies between events, greater than or equal to 4. So when we clear 4 more lines, this event will fire. And then we can use the goto mode. We want to use the goto mode because we don't want the old node to stick around, and we'll set our target to the Music Plus 1 node. We'll also want a way to get back from this Music Plus 1 node because we don't want it to play forever. For that we can use a time passed event. So say 4 seconds after we clear a quad, we go back to the normal music. You also want this node to loop, so add in your node end goToSelf. And finally put the music in that you want to play. Now, once we have music on both these nodes, this unlocks a Preserve Location After Jumping option on these triggers. This is a special option that will seamlessly blend between your two tracks. Now, you don't want to use this for node end events, otherwise your node will go to itself when it's hit its end, which means it can't loop anymore. Now we set up our Music Plus 1 node, we can save our changes, and then let's clear 4 lines. Now as you can hear, our music has changed, and our music node has gone to our Music Plus 1 node, and then shortly after it went back to the base node. Now, finding the right events to use can be tricky. While in game, you can press the F8 key to bring up the debug menu. Look for the Tetrio Plus Music Graph Debug section. This has a list of recently fired global events that you can use in your graph. Note that this is only global events. Certain local events such as node end, time passed, and random target won't show up here. Now, let's find some events to use. We'll start a new game here to demonstrate. Now that we've found a bunch of useful events, let's make a more complicated graph out of them. For this, we're going to use our back-to-back events, and we're going to have 3 levels of back-to-back music as well as our bass music. Let's delete these nodes and start over fresh. We're going to need 3 nodes. And then we're also going to use our intro music. Now, let's name these nodes intro, main loop, back-to-back 1, main loop back-to-back 2, and main loop back-to-back 3. Now we're going to set up music on those. And we'll also reorganize these quickly. Now, when a game starts, which happens when the sound effects Go player event fires, we are going to create a copy of the intro node using the fork mode. Then the intro node represents an introduction to our loop, which is standalone, so it has to play its way out. So once this node is done playing, we will go to the main loop node. And then our main loop node should loop. We'll also set up node end go to self on our other nodes so that they loop. And then we will set up the new back-to-back events we found. So whenever we clear a back-to-back, sound effects clear back-to-back player event. So when we see that, we can start the first level of back-to-backs. Then the next event we need is the sound effects back-to-back 1 player event, which will then go to the next level. Then we'll take that and go to the next level again. Now, we're not going to use the third level of back-to-back because we don't have enough music for that, so you can do that if you want. Now, when our back-to-back is broken, we'll need to use the sound effects back-to-back break event. When we get this event, on any of the back-to-back nodes that we're on, we will use that event and then we will go back to the main loop. So this event has a target of main loop. Then we will copy that to our other nodes. And don't forget to set up preserve location on all your nodes so that they transition smoothly. Now, once the game starts and we've gotten past the intro stage, our main loop will now have our clear back-to-back event waiting. When we clear a back-to-back, we will start playing the next level of music. Then when we get to the next back-to-back stage, which is defined in the base game as some number of back-to-backs, we will go to the next stage, and then we'll repeat that again for the next stage. So as you clear more back-to-backs, music gets more intense. Now let's try this in game. Now achieve the first level of back-to-backs. Now achieve the second level of back-to-backs. Now achieve the third level of back-to-backs. Now if we clear a non-back-to-back line, we'll revert to the normal loop. Now, our current graph has a bit of a problem. Every time you start a new game, a new node will be spawned, but the old ones won't be cleaned up. And your music will start playing over itself. In order to fix this, we're going to need to use the other events that we found previously. Now, in order to set this up in a way that is not annoying, we are going to use a new intermediate node between root and intro. We are going to call this node game. Now, root is now going to fork to the game node, and game is going to immediately, using the node end event, fork to the intro node. Now, our intermediate node is going to have some events on it for bookkeeping. So, whenever a new game is started, this node is going to destroy itself. This should also be a fork. Now, because this node forks to these other nodes, this node is now the parent of these nodes. When the parent is destroyed, a special event called parent node destroyed is fired on the children nodes. When this event fires, we want these nodes to be destroyed as well. So, when the parent node is destroyed, this node will then destroy itself. We can then take this trigger and paste it on the rest of these. Now you might ask, why did we have to go through putting an intermediate node in here just to use parent node destroyed everywhere? This allows us to add more events destroy the parent node without having to add them on to all the children. So, with our current setup, our music will continue playing when we've quit a game and will only restart when we've continued a game. With our current setup, our music will only stop when we've started a new game instead of ending the current game. Now, there's currently no perfect way to detect the end of a game, but using a combination of triggers can get pretty close. For this, we're going to use the menu home open trigger, the sound effects victory player trigger, the sound effects detonated player trigger, and the sound effects top out player trigger. These are all going to be set into kill mode. Now, when any of these triggers fire, all of the children node will be destroyed. So if we save our changes and come back into the game here, and remove this extra node here, whenever we start a new game, you can see the previous nodes are then destroyed. Now, we have another problem with our sound effects back-to-back 1 through 3 events. They only play in versus contexts. That means that they only play in multiplayer lobbies and in Zen when you have the versus HUD on. They won't play in Sprint or a few other places. Now, the sound effects clear back-to-back event does work everywhere. We could make a long chain of nodes that just counts out the numbers of back-to-backs using the clear back-to-back event. Every time there's a new back-to-back, you just go up a node, and then the music only changes every few nodes. But there's a more useful way, using variables. Variables are values that are recorded with a node. They're entirely user-created except for a few special ones starting with $signs. You can set a variable using the set mode. So let's create a new node to hold our variables for now. This node will be similar to the rest of our nodes. It will have a parent node destroyed, and it will be forked from the game node. Now, our variables node here is going to listen to the sound effects clear back-to-back event. And when that happens, it's going to set a variable using set mode. Now, set mode has two entries here. It has the variable name, so for us we're just going to use back-to-back as our back-to-back counter, and there's an expression. An expression allows evaluating arithmetic operations with numbers and variables. The result is then used as the new value of the variable. So in this case, we want to increase the back-to-back counter by 1. So we do back-to-back plus 1, and that's it. Now, when the sound effects clear line event fires, we're going to reset the count, because that event only fires when we've not done a back-to-back clear. So in that case, we're going to set the back-to-back variable equal to 0. Now, in order to get the value of the back-to-back counter from this variable node to our other nodes, we're going to use custom events. Custom events are similar to normal global events, except you fire them directly as the result of a trigger. Now, in our case, we're going to, when a back-to-back event occurs, we're going to dispatch a global event called back-to-back. And it's going to have the value of our back-to-back counter. Now, we also need to tell other nodes about when we've broken our back-to-back. So we're going to take the sound effects clear line event, and we're going to have it dispatch a back-to-back broken event. Now, we don't want our back-to-back broken event to fire when there's not a back-to-back going. So for that, we can use a predicate to check if there's already a back-to-back. A predicate allows you to use an expression to control whether a trigger will evaluate. If the predicate evaluates to a value of 0 or false, the trigger is cancelled. So So in this case, if our back-to-back is greater than 0, then the trigger is allowed to execute. Now, keep in mind that we just cleared our back-to-back up here, so we want to make sure that this trigger evaluates before the other one. So we got to put this above it. Now our back-to-back broken event will fire, so now we can go down to these nodes down here and swap out their events. Our back-to-back break events will be swapped with a custom event, which down here we named back-to-back broken. And then we can also replace our other nodes with our custom back-to-back broken event. And we also need to replace our various clear back-to-back events with our back-to-back event. And we're also going to add a predicate for these to ensure that we've reached the requisite number of back-to-backs. For this predicate, we're going to use the $sign because the number of back-to-backs is carried as the event value, and the $sign represents the event's value. Now we're going to do the same thing down here. We're going to do custom back-to-back, and we're going to add a predicate that this will only fire when we've done 2 back-to-backs. Same thing here. Custom event back-to-back. Add predicate. This one will only fire when we've done 4 back-to-backs. Okay, now that we've set up our custom events, let's try it in game. Made our first back-to-back, so our back-to-back node has activated. Made another back-to-back, so now our next back-to-back node is activated. Now our final back-to-back node is activated. Now if we clear a regular line clear, we'll go back to our normal node. This tutorial should be enough to get you started on making your own graphs. There's a lot of ways to make graphs, and this tutorial doesn't cover all of them. Using stems instead of premixed tracks requires a different approach, for example. And backgrounds haven't been covered at all. Keep an eye out for future tutorials for more niche usage scenarios. Keep in mind that the music graph is best effort implementation. Many of the event hooks are dependent on base game behaviors and could change at any time. Some events simply don't work at all, notably certain sound effects that aren't associated with a board. The only reliable way to find useful global events is the in-game F8 debug menu.